Hi, welcome back to the session. So we'll be starting with the parsing techniques, which is used while we parse the grammar. We have the shift and reduce parsing technique, in which shifting and reducing is happening. Shift is nothing but when there is a token, the token will be moved to the stack. That's called as shifting. And reducing is basically in the grammar, we have LHS and RHS. Once the RHS is matched with the input, the right hand side will be replaced by left hand side of the row. This is called as the reducing. So how the shift and reducing is used in parsing, that's what we are going to see with an example. So there is an input. You can see the input and we have the grammar. There are two grammars which are used in the rules section of YARC program. So we have the first grammar, STMT colon, STMT semicolon, STMT. STMT is meant for statement. Or the pipeline is used, name equal to EXP. And another grammar is EXP colon, EXP plus EXP or EXP minus EXP or name or number. So as I have already mentioned about the name and number, so we have the corresponding pattern in Plex program to identify the tokens name and number. So we have the pattern A to Z plus for identifying the name and 0 to 9 plus for identifying the number. So this is what exactly I have explained you in the previous session, how the YARC program is accepting the token name and number from the legs. So wherein we have the patterns in the corresponding legs program. So we have the input, the input which is given as A equal to 7 semicolon, B is equal to 3 plus A plus 2. So this is what exactly the input we have, and we are going to check whether the input is valid or not according to the grammar which is mentioned over here. So to do that process, we can implement the shift and reduce technique over here. So how the parsing uses this technique in order to validate the input whether it is a valid or not. Now initially the stack is empty when the first input is read. So I'll be showing this process with the animation. In each time the stack value is getting changed and the input is getting reduced. Okay, so as and when the input is read, then it will be shifted to the stack, and correspondingly what is the action to be carried out, whether it has to undergo shifting or it has to undergo reducing depending on the input, and it is whether it is matching with the grammar based on which the shift and reduce will happen. So let us take the first input. In the input statement, the first data we are reading, that is A. Listen carefully while the animation is going on. As and when I move on to the next step, so there is a corresponding changes will happen in this stack. Now, so the technique what we use is here is shifting. So what will happen now? When you read the input A can be accepted by the legs with the pattern A to Z plus, so that it can return the token name. Whenever there is a token, that will be shifted into the stack. This is called as shifting. Now, if you see the stack, it is taking the next input. So if you could see the input statement, the next input was equaled. So that is pushed again into the stack, that is shifting happens. Now, the next input is 7. So what will happen now? We will see. So the 7 is in the stack. And what happens to 7? 7 is a input that can be read by the pattern 0 to 9 plus, so that it can return the token as number. So number which is there in the second grammar. So you could see the second grammar. In the second grammar, in the right hand side of the rule, you could see the token. If the right hand side is matched with the token, whatever is there in the stack, then what will happen? The right hand side will be replaced by left hand side, and the LHS again pushed into the stack. So during the reduce concept, the technique which you can see, there is a reduce. So the RHS is reduced, RHS is replaced by LHS. The number, the token number will be replaced by EXP. Again, we push the EXP into the stack. Right? Now, the next token is what? Next input is what? Semicolon. But here, if you see the stack, if you see the stack, we have name equal to EXP. So can we match this input with the grammar, the first grammar? In the first grammar, we have the grammar in the right hand side, that is RHS name equal to EXP. Name equal to EXP. So is it matching? Yes, it is according to the grammar which is given. So what will happen? Right hand side will be reduced into left hand side. So what happens in the stack? Yes, in the stack it became STMT. Now what is the next input? The next input is semicolon. So what happens? Yes, it is shifted into the stack. What is the next input? Next input is B. So B will be it is considered as token, and it will be pushed into the stack. What is the next input? The next input is equal to, again shifting happens. So the next input is what? The next input is 3. So 3 is a number, and this number, what happened? Number which matches with the second grammar, and that will be replaced by EXP. That will be replaced by EXP. But now, if you could see the stack, in the stack, we have name equal to EXP. Name equal to EXP. But we don't reduce here. If it is, even though if it is matches with the first grammar, we don't see that is reduced, because further there are some more inputs that has to be processed. So that is why it won't be reduced to STMT. Instead, it will be as it is. The reduce will not happen. Now, the next input is plus. So what happens? It will be shifted. The next input is A. A is name. Name will be replaced by EXP. So here shifting happens. Then it has been reduced to EXP. Now, if you look at the stack, we have EXP plus EXP, and you see the second grammar in the first line, EXP plus EXP. So in the right hand side, you have EXP plus EXP. So what will happen? That will be reduced. So that will be reduced to what? EXP. So now EXP plus EXP is replaced by exp. What is the next input? Plus, as it is. Then the next input would be number. When you have number, that will be replaced by exp. So first it will be shifted to the stack, then it will be replaced by exp. So reduce happens. First shifting happens, then reduce happens. Now again reduce happens. Exp plus exp is exp, right? And here further no more inputs. So what will happen now? The input is empty, and in the stack we have name equal to exp. Can we match this with the first grammar? Yes, it is matching. So name equal to exp, again it is reduced. Reduced to what? stmt. Now in the stack you can see stmt semicolon stmt. So this will be matched with the first grammar in the first line. In RHS you can see stmt semicolon stmt. So this will be reduced to stmt. So if you could see the stack, this will be reduced to stmt, and we have reached the top of the grammar, and further there is no more input. So we can say that yes, it reaches the top of the grammar and it is non-terminal symbol, and further no more inputs. We can say that the input whatever you have given is according to the grammar which is present in the program. So our input is a valid input. So using the shift and reduce technique, the parser will parse the grammar. Whatever the input is given, which is matched with the grammar, and it says that whether the input is a valid input or not. So this is how the technique is being used in the parsing. So let me just go back to the previous slides to show you once again how this exactly the input is matched with the grammar, and finally we are receiving the result. So initially the stack is empty and you have the input. So we read, we can see the input. So when the input is given to the YARC program, the parser it parses the input, and based on the grammar which is mentioned in the YARC program, it will be matching the input with the grammar, and it processes it. So during this process, it follows the shift and reduce technique in order to parse the grammar. It follows the shift and reduce technique so that the input is matched with the, input is checked for matching with the grammar, and it is validated. So first we have the input A. So A can be matched with the lex pattern A to Z plus, so that it can return the token name. So when the first token is, for the first input is pushed into the stack, we say that shifting. So we have the token in the stack. Now the next input is equal to, so as it is present or shifted to the stack, and the next input is 7. So 7 is processed by the lex pattern, that is 0 to 9 plus, and returns the token number. So here we have the number inside the stack, and the number is replaced by exp. So we do reduce. So we have name equal to exp, which is matched with the first grammar. In the right hand side you can see name equal to exp. So this input is matched with the grammar. Input is following the rules of the grammar. So the RHS will be reduced to LHS so that you can get the STMT in the stack. So the reduce happens, and STMT will be there in the stack. The next input is semicolon. As it is shifted into the stack. The next input is B. So B is a name. So we have the name that is shifted into the stack. The next input is equal to. The next input is 3. 3 is a number. So the number which matches with the second grammar, so that the RHS will be replaced by LHS. So the reduce happen so that we get EXP. Now the next input is plus as it is. The next input is A. A is denoted by the token name. Now you can see name in this stack, that is shifting happens. Then name will be replaced by EXP. So reduce happen now. The next input would be plus. So before moving to the next input, in the stack EXP plus EXP you can see. So that is matching with the second grammar. In the right hand side you can see that EXP plus EXP, that will be replaced by EXP. So again reduce happens so that you'll be getting name equal to EXP. So the next input would be plus. So as it is, the next input would be 2, that's a number. The number will be shifted. Then now the number is matched with the grammar, that is second grammar. So number is replaced by EXP. So you can get the value EXP in the stack. Now EXP plus EXP, again it will be reduced. So now you can see the name equal to EXP. Again it will be reduced to STMT, because in the first grammar name equal to EXP, which is there in the right hand side of the row, which is reduced to STMT. So now again STMT semicolon STMT, which is present in the first grammar in the RHS. So once it's matched, RHS will be replaced by LHS, so that you can get the STMT in the stack. So finally the STMT is reached, that is top of the grammar is reached. Then there is no more input. We say that the input is a valid input. This is how the shift and reduce happens in the parsing. So we have different types of grammar. One is recursive grammar, left recursive, and the other one is a right recursive grammar. In the left recursive grammar, if you look at the example list, it's a non-terminal symbol, colon, item, then either item or we again have list comma item. So if the list is present in the left hand side of the row, sorry, the left side in the right RHS, then we can say left recursive. So it is calling by itself, the non-terminal symbol calling by itself. That is why we call it as a recursive grammar. So it is presenting in the left side. So we have the left recursive. Whereas in the next example, it's present in the right side, right recursive grammar. So the non-terminal symbol will keep on calling by itself in the, if you look at the grammar, the same thing which happened in the previous example also. So the EXP, which is present in the left side and as well as in the right side also. So LR parser, which will always prefer the left recursive grammar. LL parser will prefer the right recursive grammar. Now we'll move on to the next concept, wherein in some situation York cannot parse the grammar. So when the situation, in which situation the York will not be able to do the parsing, why it is getting stuck while doing the parsing, that's what we are going to see now. With example, I'll show you. Then again, we'll come back to this description part. So this is the example. There is a grammar. We can see the first grammar is phrase. In the RHS, we have cart animal and cart, or work animal and plow. In the second grammar, we have in the LHS cart animal. In the RHS, you can see the two tokens are given, horse and goat. The third grammar, we have work animal in LHS. In RHS, you can see horse or ox. So this is the grammar which is given in the Yak. Now when the input is given, the Yak is trying to parse the grammar. When it parses the grammar, so it has the problem, or it is not able to parse the grammar because of some problem. What's the problem? That I'll explain you with this example. Let us take the input horse and cart. Horse and cart. This is the input. So when it reads the first input horse, right? So it will be checking the grammar. Horse will be checked with the grammar. So if you could see the horse, it is present in two places. Either it can be a cart animal or it can be a work animal. But by seeing the input as a user, we can understand that yes, the horse has to be belong to cart animal, because horse and cart. If it is a horse and cart, I mean the horse belonging to the cart animal, then only in the first grammar, if you could see cart animal and cart. So the right hand side will be matched with the input and say, yes, the RHS will be reduced into phrase. But so when the input is given to the parser will be able to look ahead for a single token. Do you remember when I was giving the definition for the Yak? I have mentioned that it's a LALR grammar. It's designed for LALR grammar. Within bracket 1, it was mentioned. So that time I was telling you that 1 represents single token, which means it's look ahead for a single token. It cannot look ahead more than that token. So it cannot look that far ahead. So in this case, when it look ahead for a next token, there is a token called AND. So we have the token AND. By seeing this AND, the Yak cannot decide whether the horse belongs to the cart animal or work animal. The Yak cannot decide that the horse is belonging to cart animal or work animal. So in the situation, there are two grammars due to which the Yak is not able to parse the grammar. It got stuck to decide whether to choose cart or work animal. These grammars are called as the ambiguous grammar. So when there are ambiguous grammar, the Yak will not be able to parse the grammar because it cannot decide. Now, what we are supposed to do? So to deal with the situation, in order to make it easy, in order to make the Yak to parse the grammar, what we do some changes in the rules part. What changes we are making? If you could see the example in the down phrase, that is the left hand side of the rule. In the right hand side, cart animal followed by cart, or work animal followed by flow. So now the input which is given for this grammar is horse followed by cart. There is no and. The input would be horse followed by cart. So when the parser reads the input, parses the input, it will take the first input horse and it can look ahead for a token. It is able to recognize or it is able to look for the next token. When it looks for the next token is cart. So it will decide that in the previous grammar, there are two grammar, that is cart animal and work animal. So according to this input, since there is a cart in the next input, so since the parse is able to look ahead for the next token is cart. So obviously it has to fall under the category of cart animal. So the horse will be matched with the cart animal. So in the right hand side of the second grammar, we have the horse. So RHS will be replaced by LHS. So once you get the cart animal followed by cart. So if you look at the changed grammar in the down, cart animal followed by cart, it will be replaced by phrase. So we can say that the input is a valid one. So this is how do we deal with the situation when the ambiguous grammars are there and York is not able to parse the grammar. This is what exactly. So the parse York cannot deal with ambiguous grammar. So in which it will be having too many matches. So it can struggle which one to choose because it will be able to match more than one parse. That's what, whether it has to choose cart animal or work animal, it doesn't know. So it has to be dealt, this problem has to be dealt. That is where, so we are avoiding to use the ambiguous grammar so that it will be avoiding the situation to the parsers in order to choose the more number of parse. So because the parse Yak cannot see more than one token, it cannot look ahead for more than one token, so it cannot decide to choose which one from the ambiguous grammar. That is the reason what we do, we change the grammar so that it will be easy for the Yak to parse the grammar. So this is how the ambiguous grammars are used. Yes, of course, the ambiguous grammars are being used. But how to deal with the situation? So in order to make the York to parse the grammars, we change the grammar slightly so that it can do the process. So with this, we'll be ending the session. In the next session, we'll be starting with the York parser format. So how the York file format would be. So similar to Lexa, as we have already discussed that in Lex, what is the format for the Lex? So how the Lex has to be. That is what exactly here also we are going to discuss about how the Yak program will be. What is the structure of the Yak? What are the sections will be provided in the Yak, so that we'll be able to write the program, especially in the Yak format. We have similar structure like Lex. What are the structure we use in the Lex? Same way we'll be having in the Yak also. Only thing is, in place of the patterns, we are going to keep the grammars. The rules we are going to keep in the rules part. Otherwise, the three sections, whatever we use in the Lex program, Same thing we'll be going to use in the YARC also. Okay. So we'll discuss the format in the next session.